let's just talk about this front side. Let's just talk about this front side for today. Now, when we look at this, we're not at the point yet where we know the lines are parallel. We start off with just the lines being all over the place. And what we need to do is look for what relationship, what connects those two angles. So when I'm looking at angles 1 and 6, they have that transversal in common. So if it helps you, and I know it keeps switching around, so if it helps you, sometimes I'll lay my pencil across the line that's the transversal. So right now, lay your pencil across that line that I have highlighted, and then you can see that 1 and 6 are corresponding angles because they're in the same position with respect to that transversal. They are on the same side of that transversal, and they're each tucked underneath those lines that intersect, that create that relationship. So it helps me sometimes to lay my pencil over top of what is the transversal, and then that helps me look for those intersecting relationships. So when I look at 7 and 12, it's no longer this line, but now this line that connects 7 and 12. So go ahead and slide your pencil so that it is across this line. And when I look at 7 and 12, what did you decide that they were? Those are consecutive interior angles. So here's the deal. If right now you're like, I'm so confused, I'm wondering, what kind of practice did you do before you walked in the door today? What kind of independent practice did you have? Did you do the math base? I hope so. Did you review your notes? I hope so. Because we learned too many vocabulary words for you to be sitting here cold and try to remember. It's not going to work. So if you're struggling with, I forgot that word, where does it come from? Go to your notes and open them up. Because every single time that you open up your binder and you leaf through your pages that are in order, you're reviewing the story of everything that we've talked about. Flip through, flip through, flip through. Ah, here's the notes. And all those vocabulary terms. 2 and 10, what are they? Corresponding. 4 and 9, what are they? Consecutive interior. 6 and 10, what are they? Alternating exterior angles. 5 and 11, what are they? Alternate exterior. 4 and 10, what are they? Alternate interior. 4 and 10 are interior. 3 and 10. Consecutive interior. 7 and 4. Corresponding. 9 and 7. Alternating interior angles. Very good. If you struggled with any of those vocabulary words, make sure that you save this and quiz yourself and go over it again and again. All right. So given that lines A and B are parallel, here comes the next level. Turn your page over. Given that lines A and B are parallel, we can draw our little triangles to let us know that lines A and B are in fact parallel. We have some relationships going on between angles 1, 2, 3, 4, 5, 6, 7, and 8. Turn to your group mates and dive into this part of the warm-up. On your mark, set, go. You're using Would you like your own? Oh, would you like your It's equal or equal to 1.
I think they
Okay, so you don't need this. Okay, because then we're going to go through the back of these sheets. So we want to make sure you got that too.
3 is
All right, come back. Let's talk about these. Given lines A and B are parallel.
so just gave up on this.
Circle the correct relationship. And what we're talking about relationship-wise is which is it? Are they angles that are congruent because they have the same measure? Or are they angles that are supplementary because their measures add up to 180 degrees? You're going to figure out a pretty clear pattern in geometry. Everything is one or the other. Are they congruent or are they supplementary? All right, angles 1 and 5. When I look here at my transversal, 1 and 5 are on the same side of the transversal, and they are positionally in the same place with respect to their lines, so they are corresponding angles. All corresponding angles are congruent if the lines are parallel. We were given that the lines are parallel, so we're in good shape. 1 and 5 are corresponding angles. Their measures are equal. Another example of corresponding angles, we can talk about a ton of examples. We can talk about 2 and 6 are corresponding angles. We can talk about 4 and 8 are corresponding angles. We can talk about 3 and 7. So whichever of those you listed together as a pair would be a good answer. All right, now let's talk about 3 and 6. 3 and 6, do you see how they are on opposite sides of that transversal? So I know that the word that I'm going to start off to describe them is going to be alternate. And some people say alternating or alternate. I had one kid yesterday keep on calling them alternative, which, alternate, like back and forth. 3 and 6 are alternate, and are they inside of those parallel lines or outside? Inside. So again, we're not creative in naming things in mathematics. They are all our alternate interior angles. The relationship between alternate interior angles is that they have equal measures. They are going to have equal measures. Another example of alternate interior angles are angles 4 and 5. And that's your only other choice. You only have one option. 1 and 8 are on opposite sides of my transversal, but instead of being inside, they are outside, so they are alternate exterior angles. They are also congruent. And my other example are angles 2 and 7. 3 and 5 are our consecutive. Sometimes we call them same side interior angles, and they are our friends that are supplementary. 4 and 6 is another example. If I'm ever confused and I can't remember which of those interior angles are supplementary and which ones are congruent, sometimes what I like to do is I like to draw myself a very exaggerated version of my parallel line system. If I draw a super slanted transversal, then I can see that all of my fat angles are going to be congruent. So when I look at all my angles that are vertical angles that are created, every single angle inside that is either a flat or a skinny. If it's an obtuse angle, that's going to be our angles that are fat, that are bigger than 90 degrees. If it's an acute little angle, that's our angles that are skinny. Those are going to be smaller than 90 degrees. And if I draw every single angle, I can see that any time I have a fat and a skinny, they're supplementary. So skinnies are congruent with skinnies, and fats are congruent with fats. And all you need is one angle measure to go to town. So let's just say that I told you that this was a 20-degree angle. With your partners, name every other angle, the other 7 in this parallel line system. Turn the top, go. What the heck? No, not 1,620. For sure not. 160 degrees. Everything that's fat is 160. Everything that is skinny is 20. So if it helps you, that transversal and those 2 parallel lines create 8 angles, 4 fats, 4 skinnies, obtuse and acute. All of our fats have the same measure. All of our skinnies have the same measures. 1 fat, 1 skinny, supplementary. Does that make sense to you? Sometimes kids find that helpful. Okay. Take out, please, your 3 pieces of paper I gave you last class. You had 3, 0, and 2 note pages, 3, 1. A and 2, 1, B. Your first note page was where we talked about and reviewed parallel, perpendicular, and skew. We spent some time reviewing what it means to be parallel, what it means to be perpendicular, what it means to be skew, and we talked about the transversal and then those angles created. On the back, I believe we covered up through 13, so we'll go ahead and talk quickly about 14. Use the cube to name each of the following. All the lines that are parallel to BC. If I have line BC here, any line that is parallel to it, and remember, parallel lines exist in the same plane, but I have the capability of having multiple planes. So each of those lines are parallel to BC. You should have had FG, HE, and DA. When you listed a pair of parallel planes, as long as they were sides of the box. So for example, if I color in this side of the box, and I color in this side of the box, those are 2 planes that are never going to intersect. And if you think about something as simple as a tissue box, any opposite sides are going to be parallel. So we have 3 sets. 1, 2 around the one side, and then our basics. So those are going to be our parallel planes. When we talk about skew lines, we want to have a line that is not intersecting with AE. So as soon as I draw AE, I have these two lines that are parallel to, or that were part of our parallel conversation to BC. We can see that they intersect. We have these lines that intersect AE. So when I'm talking about, and I can remove this line here, oops, not that one. Now I can. So when I'm talking about line AE, all the lines I have up there are right now intersecting AE. Any line that's parallel to AE, here, here, and here, are not going to be skew because I can have a plane that exists between them. So guess what? The 4 lines that are not colored in right now, and one of those is skew. Line FG, not parallel, not perpendicular. Line BC, not parallel, not perpendicular. Line DC, not parallel, not perpendicular. Line FG. Make sense? Identify all types of angles in the diagram. Name the 2 lines in the transversal that form each. Okay, so this diagram can get a little confusing, and I really encourage you getting a highlighter to try to figure out, because when I'm talking about corresponding angles, I see this transversal and these 2 lines giving me angles 5 and angle 7 for corresponding angles. I think that's all I see. If I'm talking about alternating interior angles, if I look at these 2 lines here with this transversal, my alternating interior angles, I have 3 and 1. Two and 4 are also alternating interior angles if I stick with this line system. Any others that you see? 7 and 4 I don't think are alternating. A is the transversal. I'm not sure about that one. Let's get rid of all the noise. So you're saying A is the transversal? And if I'm talking about lines B and C, that's going to be 1 and 3. 7 is not, and 4 is not, because see how 4 doesn't come down and touch the screen? Do you see it now? Okay. Same side, interior angles. I'm seeing let's get rid of our colors. Same side interior angles. I see 7 and 8, that's it. So here's the lines, and here's the transversal. I see angle 7 and angle 8. 4 and 5 can't be it, because it would have to
One
be.
and four.
Say that one more time. 2 and 3 are not, because they're on the same side. 2 and 3 are on the same side of this transversal. This one?
Yeah.
But 2 doesn't come all the way up. Right? It would have to be 2 plus 7. Right? If this is my parallel line, 3 is good, but 2 is not. It would have to be 2 plus 7. Do you see it? Stretch your brains. You can do it. Any others that you see? Yeah. 2 would have to go all the way up.
What about if you use parallel lines being
Parallel lines. Here, let's erase the noise. Oops. Parallel lines. Go ahead. Say it one more time.
D and E?
So if I had parallel lines D and parallel lines E, which transversal? If I had transversal A, in order for me to have consecutive interior angles, angle 4 would have to include this, right? So 1 isn't enough. It doesn't go up to the line. Do you see it? Yeah. That's a tricky diagram. Yeah? Are you with me? Okay. With your partners, find the alternating exterior angles. Remember, say go. 2 and 4 are interior. We want exterior.
No, because it's good that one side of the angle is gone. Because the one angle, it also includes, it also includes speed. It's not just A.
I'm going to go with 7 and 6. Anybody want to argue? 7 and 6? We good? That diagram's tricky for sure. All right. Flip over to the other side of notes 3-1. On the other side of notes 3-1. Check your work with mine. Corresponding angles E. I love this one because it's all about angle A. So when you look at A and E are corresponding, A and H are alternate exterior. Angle F, that's an F. A and F are same side exterior, A and D are vertical. And then if I'm forming a linear pair, A and C and A and D. Everybody good with that?
Where's the first one?
That's an E. Would it be easier if I did this? Hold on. Hold on.
Yeah.
Yes. Otherwise it looks like an L.
That's it. I'm sorry. All right. Hey, when we talk about corresponding angles, this kind of goes to what we were talking about. Make sure your notes are good. 1 and 7 corresponding. 2 and 4, 3 and 5, 8 and 6. That same idea with all that. Alternating interior and exterior. There are 2 sets of those. Consecutive interior, 3 and 4, 8 and 7. Same side exterior. I don't like them. It's okay. 2 and 5, 1 and 6. Hey, I love this next question. 4 pairs of angles that are guaranteed to be congruent. If you don't know the lines are parallel, you have to stay within the family. So if you don't know the lines are parallel, the only things that are guaranteed to be congruent are your vertical angles. 1 and 3, 2 and 8. The only thing that's guaranteed to be congruent are your vertical angles. 7 and 5, 4 and 6. 8 angles that are guaranteed to be supplementary. That's all of our adjacent angles that form those linear pairs. 1 and 2, 2 and 3, 3 and 8, 8 and 1. 7 and 4, 4 and 5, 5 and 6, 6 and 7. Any questions on those conversations? This one was a tricky one. If you have a transversal that switches each time, it creates different angles within those angle measures. Will your partners please discuss B and C and D of this? Tell me what you got for your homework. Your mark is set, go. Transversal A is highlighted in blue. When I'm looking for corresponding angles, that's going to be angles that are located in the same position, which means that they are tucked. I picked angles 1 and 2 in red. They're on the same side of the transversal. They're both tucked underneath of the lines. There are other ones, obviously. Transversal B, I highlighted in yellow. And when I talk about alternating interior angles, I went ahead and put them in green, angles 1 and 2. When I talk about transversal C, I highlighted that in green, and my consecutive interior angles are in blue. This is a real exercise in looking at something and trying to figure out. It's hardest when we do this kind of stuff for you, and I got some promises. We're not going to see a whole lot of these. We're going to dive right back into our conversations where the lines are parallel. At the bottom of notes 3.1b is what we're going to be talking about more and more frequently. At the bottom of 3.1b, we want to make sure you understand, hey, when somebody gives you some parallel lines, you can right away jump in labeling which angles are going to be obtuse, which angles are going to be acute, and every single angle within that whole system, once the lines are parallel, is one of those two measures. Is it your fat or is it your skinny? And as soon as they tell us that the measure of angle 1 is 118 degrees, I automatically have the measure of 4 angles of that system. Because if the lines are parallel, my vertical angles are going to be congruent, my corresponding angles are going to be congruent, my alternating interior angles are congruent, my alternating exterior angles are congruent. Here they all are. These are my 3 sets of angles that right away I know are congruent. When I want to find my supplementary angles, it takes one math problem. What is that one math problem?
180 minus 118.
Yeah, I struggle with subtraction. Anybody else? So when I was a cashier in high school, I learned to count up and adding on. It goes like this. If I'm looking at 118 plus 2 takes me up to 120. Anything that's a multiple of 10 is one of my friendly numbers. So plus 2 takes me up to 120. How do I get from 120 to 180? 60. So I'm adding 62. The difference between 118 and 180 is 62. I count up when I subtract. Anybody else do that in their head? Yeah. The number games that you can play in your head can be kind of fun sometimes. When I'm bored, that's what I like to do. So I don't necessarily subtract, but what I do is I look at counting up. Plus 62 gets me up to 180. And that means that every single one of those skinny angles is going to be 62 degrees. They're either vertical, corresponding, alternate interior, alternate exterior, all because of this relationship here that makes them supplementary, or this relationship here that makes them supplementary. But that makes it easy for you to fill in what angles 2, 3, 5, and 4 are. True? Kind of cool. Turn the page over. On your second page of homework, I asked you to do. What is the measure of angle 1? 180 degrees. No, it's not. It's 100 degrees. So here's where we're going. We're going to be using the properties of parallel lines to help justify why it is what we're doing. So I'm given that those lines are parallel by the diagram. I'm given one 39-degree angle, and right away I can, out of the gate, say the measure of angle 1 is 39 degrees. How come? How come?
Because alternate interior.
They are alternate interior angles. Nice job, Christian. So they are alternating interior angles. What that means is if the lines are parallel, then alternate interior angles are congruent. So now I'm going to go ahead and say the measured angle 1 plus 7x plus 1 is equal to 180 degrees. Who says that? Yeah, they are a linear pair. So the linear pair postulate says anytime you have two angles that are adjacent and supplementary, they are linear pairs. Linear pair postulate says that go ahead and make them 180 degrees. What makes me able to say 39 degrees plus 7x plus 1 is equal to 180 degrees? That is my substitution property of equality. By the way, I combined some like terms. 39 plus 1 is 40, and then I subtracted 40 from each side. Says my subtraction property of equality. Divided each side by 2 says my division property of equality. I love this proof. Given those two lines are parallel, how can I get angle 1 and angle 5 congruent to each other? And what's interesting is you have to figure out a way to jump families. Stick with me here on this one. Do you see this blue transversal is about these two lines? Do you see this red transversal? No. This red transversal is still about these lines, but 1 and 5 do not have the same transversal, so you can't call them alternating exterior angles because they don't have the same transversal. So you have to use the fact that you've got two sets of parallel lines connecting them. This set here and this set here. With your group, go ahead through and talk through this proof, making sure that everybody understands. On your mark, set, go. Unfortunately, we expect you to remember everything from all of the units. And you're like, seriously? We're like, yeah. So if you look back in your notes, and I'm telling you what, if you don't have a binder that tells a story like my binder, they don't know what to do to get you to figure out how to get a binder. Because if somebody says that that's in notes 2.5, all I gotta do is page through my binder until I get to notes 2.5. And once I get to notes 2.5, hold on. Hold on. I'm working my way. Hey, found them. Once I get to notes 2.5, there's what Brian described to us. Here it is. On that same day, while you're going back and looking at those notes, you're like, oh, that's where we run the vertical angle theorem. How about that? Congruent supplements and the congruent complements are in the same look. Okay, we got that. Oh, there's what, oh, those right angle theorems in there too. That's where, oh, all right angles are congruent. Of course I know that. The two angles are congruent supplementary, each is right angle, and then that. So we have to know where to find these. And we have to know that they're at already. And if we forget them, it's okay. We just need to know where to go get them. And I love that idea because 2 and 4 are both supplementary to the same angle. 2 and 3 are supplementary. 3 and 4 are supplementary. Somebody wanted to use the transitive property of supplementary, and I went, that's very sweet. But you understand that there's no transitive property of supplementary, and they wanted to name it. They're like, well, can't I call it after myself? It might be fine. We declare the transitive property of supplementary. I said, no, actually, I understand where you're going with that, and that's why we have the congruent supplements. And they're like, well, we forgot about that. I'm like, well, you're not going to forget about it now. Anybody take out their pink piece of paper and add it to their proof pantry? Ooh, congruent supplements, congruent complements. Anything else from 2.5 you forgot to include? Because when you're stuck, just like when you're hungry and you go open up the refrigerator, you look inside, or you open up the pantry and look inside, you want to have it written down so you don't forget it again. Congruent supplements theorem. Then we have the transitive property of equality and our vertical angles theorem, and then our transitive property of equality takes us down to 1 and 5. Pretty cool proof. I love that one. Make sure you have it in your knowledge base. Sound okay? What do you think of my flow chart? Does it work? How does a flow chart work?
They'll ask you a question, and anything is enough to you just follow down.
Follow down. So you can have more than one path, right? You can kind of work your way through. I thought this one was funny. I love how they all lead to no problem. Wouldn't you like that to be for geometry? Any Beatles fans? Do you guys know who the Beatles are? Did you ever hear the song Hey Jude? That's the one that goes na 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 na. So hey Jude, don't make it bad. And this whole song can be written as a flow proof. As a flow chart. Kind of cool, huh? All right. Here's what the so what now what is for this. Your first way of looking at the proof is in a traditional 2-column sense. It's in a traditional 2-column sense. And you can go ahead through and look at this as a group. Your second piece of paper has the same proof as a paragraph. So you can look at these two as a group, try to fill in the answers. The third piece of paper that you have has the same proof as a flow proof. When you get back from lunch, that's what I want you to dive into. Go ahead. So let's talk about this a little bit. You have to be willing to dive in and get messy with these proofs. I am struggling to grade your quizzes because I can't give you any points for blank proofs. And that's what I had a lot of. The more you do it, the better you get. So if you sit back passively wondering who has the bathroom sign and how quickly are they going to come back till I can go, then you're missing out on the opportunity to get in and figure out how to do these proofs. So the first version of this proof was on purpose supposed to be the easiest. I passed out note pages that have all 3 of the proofs on them. So whether you want to work from the half sheet, whether you want to work from the half sheet or the note page, that's up to you. But I want you with me talking about each of these 3 proofs. Are you ready? if we are given that the measure of angle AEC is equal to the measure of angle BED, that looks like this. AEC has the same measure as angle BED. Okay. I want to prove that angle AEB is equal to or has the same measure as angle DEC. So these two red angles are what I'm trying to prove are congruent. So I know right away I'm going to have some angle addition action happening. Because if I'm given the two bigger angles are equal to each other and I have to prove the two smaller angles are equal to each other, I'm obviously going to take away that one in the middle that they share. Does that make sense to you? That plan for the proof is the most important step one. If you know what you're doing, then doing all those little details will fall in line. All right, so the first thing that we're given is the measure of angle AEC is equal to the measure of angle DEB. Now, if I go down to my paragraph proof, we don't have that sentence yet. We start here with the given fact that AEC is equal to measure of angle BED. So it comes out of order. If you go to your flow proof, that one's going to be right up at the top. AEC is equal to DEB. All right, back to our two column. By angle addition postulate says that AEB, measure of angle AEB plus the measure of angle BEC is going to equal AEC. Then I have the measure of angle AEB plus the measure of angle BEC is equal to, check it out, my substitution property of equality. This is what I'm going to be substituting, DEB. My next addition, DEC plus BEC, that's going to equal to DEB, and if you'll notice, this is where I have that connection between them being equal. So I can go ahead and set those two mathematical sentences equal to each other. DEC, so AEB plus BEC is going to be the same as DEC plus BEC. And then, of course, because I have this listed twice, I'm going to go ahead and subtract those two quantities from each side. And that's going to give me what it is I set out to prove. AEB and DEC have the same measure. Two-column proof is the most popular favorite way because it goes down systematically one at a time, one at a time, one at a time. Some of you will prefer the idea of a paragraph proof. So now that we understand what it is we're trying to do, when we go down, we can then talk to ourselves almost as if you're explaining it to a friend. Hey, by the angle addition postulate, the measure of the angle AEB plus the measure of angle BEC is equal to the measure of angle AEC. Using the substitution property equality and the given fact that AEC and BED have the same measure, you can conclude AEB plus BEC is going to be equal to DEB. Using the angle addition postulate and the transit property equality, I can then show that those two things are the same. AEB plus BEC is going to be equal to BEC and CED. It flows from the subtraction property of equality that AEB and BEC are the same. We okay with that one? All right, so the cool part is when we take that same proof and now we look at it a third way. When we talk about a flow proof, we can have two different things happening at the same time. I want you to think about if you're making spaghetti. You've got a pot of water on the stove that needs to boil, and while that pot is heating up, before you can pour your pasta in it, you can get the sauce going. You can make a salad. You can get the bread in the oven. You can be doing something else while you're waiting for that to heat up. As we do a flow proof, what's written underneath the flow proof is what supports whatever is inside of the box. So if those two angles are given to us as having the same measure, AEC has the same measure as angle DEB, I can jump in and find my angle addition postulate, where I have A and E, and this is D, right? So AEC is going to be AEB plus BEC. And then it's kind of nice because visually I can look at those two things together. And because I can see that they are the same, AEB and BEC is now going to have the same measure because I'm going to substitute that in and call that DEB. DEC, BEC is going to be equal to DEB. And now because I can see that these two values, I can go ahead and put that transfer property of equality and put AEB, BEC, DEC, BEC. Then of course, BEC subtracts out, and my subtraction property of equality defends that. Same proof, three different ways. So what you have on your landscape note sheet, did everybody get that?
Yeah.
You guys a landscape note sheet? What you have on that landscape note sheet is this idea that same proof can be done three different ways. So we're going to get to a point where I'm going to ask you to prove using a paragraph proof, prove using a flow proof, prove using a two-column proof, and one of these days I'm going to say prove any way you want. And if you're a flow proof person, you'd be like, I'm doing this one. If you're a paragraph proof person, you'd be like, oh, I think this one's easier. If you're a person that prefers the idea of your two-column, you can stick with that. On the back of this sheet are some flow proofs for you to take a look at. One that's set up for you, and the other one that has a bunch of little tickets for you to use and put into place. I'd like you to add this to what you look at tonight for homework and see how you do with this idea of a flow proof. Sound okay? All right. If you moved, you can return to your original seats. All those little half sheets of paper, they can be trashed. If you have your answers written down on your notes, I'll give you a minute to get reorganized. to throw out what you need to throw out. Okay. So our next big idea comes to us by the converse of all of the angle relationships we had in last class's topic. Last class we learned if the angles are perpendicular, then we have all these cool relationships. This class, we're now looking at the converse, and by the converse, yeah, it's over there. Now we're talking about the converse. And the converse is going to then go ahead and say, hey, instead of proving the cool relationships between the angles, now we are going to use those cool relationships to prove that the two lines are parallel. So with the converse, because not all the converses of theorems are definitely guaranteed to be true, like our definitions. If the converse of a theorem is true, we're going to take the time to talk about it separately and make sure we know that that converse is the reverse of our P and Q. So in the last lesson we had, if the lines are parallel, then all these cool relationships are true. Now in this lesson, we're going to say, if I have congruent corresponding angles, then my lines are parallel. So first I need the congruent corresponding angles, and if that's true, only then can we talk about my lines being parallel. When we talk about my alternate interior angles, it's going to be if my alternate interior angles are congruent, then my lines are parallel. Consecutive interior angles. If my consecutive interior angles are supplementary, then my lines are parallel. If my alternating exterior angles are congruent, then my lines are parallel. So what's interesting is we take every single angle relationship we already know the vocabulary words. So the first lesson was let's learn these relationships, got it. Second lesson was if the lines are parallel, here are which ones are congruent and which ones are supplementary, got it. Now we're going to flip it around and say, hey, if you come across those situations, then you can go ahead and say that those lines are parallel because that wasn't necessarily given to you. So when we look here, we can say which lines are parallel if 1 and 2 are congruent. Ask your partner which one they think. What relationship do 1 and 2 have? They are alternate interior angles. Yeah, so angles 1 and 2 are alternate interior angles if those two angles are congruent, then what can I say? If angles 1 and 2 are congruent, which two lines are parallel? Yeah, then C is going to be parallel to D. Yeah, this arrow is pointing to this being a true statement. If 1 and 2 are congruent. Okay, flip it around the back. So here's an interesting part about geometry is we cannot use a theorem until we prove that the theorem is true. So I know there's an alternate exterior angles converse that's written out on the other side of the paper, but we can't use it until we prove it. So when we have our alternating exterior angles converse, that's the one that says if I'm given these two angles are congruent, can you prove that M and N are parallel? So we're going to take what we know and try to work back through what Euclid has given us as an absolute understanding. So first of all, angles 1 and 2 are congruent. That part is given to us. We don't need to worry about it. What's the relationship between angles 2 and 3? Yeah, those are going to be vertical angles. So I know that they are congruent. What can I get from this conversation? Abdullah, go. Yeah, angle 1 is going to be congruent to angle 3. And you're like, how did he get that? Because do you see how they are both congruent to angle 2? That's my transitive property of congruence. Make sure you use the word congruence, not equality. All right, so now through vertical angles and through my transitive property, you can see I ended up with angle 3 and angle 1 congruent. What's the so what, now what? Why do I care about that? What do you think, Rachel?
Because that means that the lines are parallel, the M and N. Yeah.
Yeah, and this is why she can use this one, because the postulate is what Euclid gave us. So when you take it back to corresponding angles, I can say the converse of the corresponding angle says if the two corresponding angles are congruent, then the lines are parallel. So when I talk about M being parallel to N, that's going to be the converse of the corresponding angles past U length. If you want to, just make sure that I can know what it is. And if you don't use the word converse, you don't get it right. Because the corresponding angles postulate says if the lines are parallel, then corresponding angles are congruent. It's the converse that says if the corresponding angles are congruent, then the lines are parallel. So you have to keep straight in your head, are you proving congruent angles or are you proving parallel lines? All right, so for homework tonight, you have a sheet of proofs. Yes.
For this sheet.
The back of that sheet. Basically, if we don't get through the notes, listen, no math space, except the one I've already given you.
What about this?
Yes. should already be done. So the same as you did with two groups.
Oh, yeah.
So this
So
is-
you don't do the one.
No. It's still in though, because that's what you do with your group. Did everybody get that homework?
Yeah.